start with maybe just a brief introduction on it and how it says basically the architecture is structured. Now, this is probably a little bit too detailed information for what we generally need. But the idea around it is it's trying to keep the same flexibility as Nextflow, both in terms of the way Tower is installed and Tower is run, but also in the way that the execution is run. So under the hood, it's running Nextflow itself. So everything we've learned is completely applicable to that. And then also in the way that it's able to be interacted with. So this is not like a typical like a SaaS service where it's not something like similar things like DNA Nexus where you can log in there and you upload your data and you run in their compute. The idea behind it is it's supposed to be integrated into your compute. And this means that you can install Tower, and both for Sangya and EPI, we have instances of Tower, maybe multiple actually, that are available. The other part about it is it integrates in with the way that you want to work. So if you want to make Tower part of like an automated system, you could, for example, use the API here, link it in with everything you see, also the CLI. So instead of saying Nextflow run, you can say Tower launch, and it takes care of a lot of that stuff for you, which can be useful. So the way that it's structured is it's a full stack web application. So this means that it's got a front end, it's got a back end, and it's got a database on the back of that. And the database is going to hold all of that like log information, all of the history of our runs, individual tasks, etc. And it links in then with the kind of key things that we've seen, which is the repositories, including like your GitHub or your GitLab, etc. The location of your code. Links in with the container registries, so things like Docker Hub that we saw before, as well as other data sources. So you can have secrets in there and link in with like federated data sources. If you need to access those things, you can then link them in via the compute environments, which we'll see in a moment. When it runs, when you say Tower run, you're launching a Nextflow job into a platform, and there's basically the same compute platforms that which we spoke about today inside of there, and then the individual tasks then become containerized tasks. There's also a cloud VM cost thing, so it's got cost of all of the cloud providers on there, as well as like a whole bunch of stuff we're going to see around building that out from the front end and making it kind of easy to launch there. So the first thing that you should see is the community showcase. And the community showcase is basically a place for people to run pipelines, get a feeling of how it's like to launch a pipeline inside of Tower itself. So your view will be slightly different than this, but you should see that the pipelines that we have here. And the first, I guess, use case really typically relates to launching a pipeline which we've already pre-configured. So all these are pre-configured pipelines. They're tied to a compute environment. So they're tied to, in this case, AWS Batch. And we can go through and launch that. I'm going to select the RNA-seq pipeline here. And then this is going to render for me a form of essentially the parameters. And these are Nextflow parameters. So this is the equivalent here of -- input, -- output, etc., all the way through. And I'm just going to select some options. I'm just really actually, you can just launch this by itself. Once this is launched, we're going to see that the individual Nextflow task here, the job is going to be submitted to the cluster, or to the queue in this place. And as you can see, we're working in a shared environment, so I can see all of yours as you run through. So I can go through and watch your executions as you kick those off. And again, we've got to see someone who's already launched this. We can follow along this. So here's the command line. Here's the parameters. This is the Nextflow parameters, the Nextflow configuration. So here it's taken the configuration that we had, and these are NF core pipelines. So there's a lot of config here, but that config is taken from the location of essentially this is taken from the repository. This is taken from the location we've launched Tower from, and it's pulled all that in, and it's showing us this list of parameters. So it's basically a big kind of history of, big collection of everything we have. We can see the execution log, and this is the same as if we were running Nextflow run with NC log. So you can see here, this is the start of the pipeline. In NF core, they give you a whole bunch of information around how that runs. So you can see the version that we are using, the run name, and here you can start to see the things like the working directory. So where this is running and how this works. You have the log files. You can also have reports, which I'll show you a completed one for this. And in terms of the runs, here, so this one was completed. The reports here allow me to see, for example, the multi-QC report, and we'll see how we can choose this and specify this in a moment, as well as all sorts of things around PDFs or any kind of data that we're outputting here. As those tasks are running through, these correspond to the location where they're running. So if you have a cluster, these correspond to the clusters. The LSF has a concept of submitted and running. So pending is sort of waiting to be submitted. Submitted means it's been sent to the cluster, but it hasn't been scheduled on the cluster. Running is obviously running, so that task is actually running. There's cached, which is the tasks which have been cached from Nextflow. This is Nextflow resume functionality. Built in here, we have succeeded, obviously, and then failed. And this is happening at the task level. So we can see this pipeline's got 200 tasks. And we can start to see a little information on where it's run here. So this was the user who launched this. This is the location of the work directory. So here you can see it's S3. It's NF Tower bucket here, and we have it's running on AWS batch. And this is the job ID, essentially for the operation ID of batch, the computer environment, which we'll get to in a moment, and the version of Nextflow that we have. Okay. We also have information for the aggregate statistics. So this is time, CPU, etc. And we can start to see some information on the core. So this ran at peak, it ran 50 CPUs. And it ran 26 tasks at peak. Obviously, there's none running currently, and the efficiency and memory are there. When we jump in here, this should make a little bit more sense now, given the fact that we can say, okay, let's just show me the samples that were related to the wild type samples, let's say, and I want to look at when we ran star align. So select that. This is the script section. So this is the section that runs really the part of the task, which is the script. There you have the status, so the exit status of that, the work directory, the environment here, and then you have the execution statistics. So the time that it ran for, ran in this container on this queue. This is the same queue that you could specify from process.queue. The CPUs, memory, time, etc., as well as the cost database on the back, and you can compare that with the resources that it actually used there. You can also jump in the execution log. So this is the .command.log inside that working directory. So you can often be in a situation where it's very deep. So you're like in an S3 bucket, in this scratch location, in this individual task working directory. Accessing that is super easy and useful. Download that information and make that all accessible. And then, of course, compare that information with the resources that we've actually used. So whether that's time, duration, memory, and all of this is agnostic. So the same thing happens if you run on LSF, same thing with Kubernetes, same thing with Google Life Sciences. It's the same interface with those interactions. And kind of Nextflow makes that really possible. And this is a kind of point that it's not just being another SaaS platform that you can go run your pipelines in. It's actually a very powerful tool for doing so. Inside the navigation of this, it works a little bit like GitHub, or if you're familiar with kind of Git, where you have the concept of an organization and then projects. We have the concept of organization and then workspaces. So here you can see you've got the access to the community showcase, but you've also got your own personal workspace here. And if you go in here, you'll see that you don't have any kind of pipeline saved in here. What we're going to do, though, is we are going to create a pipeline. And I'm going to show you sort of running through this. This is really kind of for demonstration purposes, but the idea would be that we are going to create a pipeline which we're going to run against a compute environment that we create. Now, creation of the compute environment requires credentials, because obviously it has to link in either with your cluster, with your LSF cluster, with your Kubernetes cluster, with your cloud. And therefore, that's something we're going to do afterwards, but I kind of want to show you through the RNA-seq pipeline that we built and how could we place that here and make it available for other people to run either in an organization or inside our own workspace so that we can run it at a later date. And the core concept here is we are going to create a new pipeline. So I want you to go to your workspace here, and then I want you to select a new pipeline that you're going to run. The first thing that we're going to do is give it a name, and I'm just going to call this our EBI demo RNA-seq pipeline. You can give it the name that you prefer. The thing that we're going to select here is you won't have a computer environment set up, so you could ignore that for now. What we want to place, though, and what's the kind of important part, is the pipeline to launch. Now, this is the Git repository of that workflow, which is a definition of that workflow. And in our case, the pipeline that we had, we pushed it to this repository here. So we can either select this here. If you want to go choose one that you've already created, you can do that. If you want to go to NF Core, you can go pull one in from there as well. So let's just go to show you what that looks like. If you go to NF Core, take any of these pipelines. For example, just take the first one if you want. You can just select that Git repository. This could be public, private. You can link in with our credentials. I'll show you in a moment. The first use case, though, is we are going to, in this case, let's just take the RNA-seq one here. And I'm just going to copy that one there. Actually, I'll take the very basic RNA-seq one, and I'm going to then place that inside my Tower pipeline to launch. Okay. Select that, and that's good to go. Now you can see this little blue circle. Can you remember when we ran and we chose a specific version? Remember we said Nextflow run, and we could say -r, run version 2, or run this branch. Well, this enables us here. This is exactly what we're doing with the revision number here. And it's gone to GitHub and showing us all of this information. So we want to say, I want to run version 2 of that pipeline, let's say. And just a reminder, when you push a new version, you could provide a commit ID. You could provide it as a branch. All of these tags, 2.1, 2.1, etc., become here. They automatically get printed for you, or get shown for you here for doing that. So let's run version 2. And the final thing that you won't have there is the work directory, but this is just linked to this. So if I run that pipeline here, and I run it on, in this case, S3, because it's my AWS batch I've got set up, the working directory is S3. If I want to run that in Kubernetes, this is -scratch, because this is a persistent volume claim on my AWS cluster. Same thing with GKE. This is the same pipeline that I'm launching now in a GKE cluster. Same thing with Google Life Sciences here. For setting that up, now the working directory becomes a Google storage bucket, and Slurm, it becomes a path on my shared file system. So the principles of Nextflow here are really being applied, that we are defining the workflow we wish to launch, where we're going to run it, and choosing a revision for that. There's a bunch of advanced options if you want to specify the config file, Tower config, I'll show you in a moment, etc. All of this becomes, for the most part, we are defining a couple of things: where we're going to run, which pipeline we're going to run, and the kind of version of that, and then making that available here. And by creating a pipeline, it's a combination of the workflow, the compute, plus some default parameters. Those default parameters could come from a profile, they could come from something that you've set up. But now you can see this pipeline is available for me here. Okay, if we see here in the pipeline, when I select this now, I want you to see the difference. This one here is run here. There's two real kind of launch screens that we have as part of the pipeline definition. This is what we call the advanced launch. And the advanced launch is really for people familiar like Nextflow. So hopefully with you folks at the moment, today, we understand what these things are. We understand the workflow. We understand this is a repository and the revision, etc. But sometimes you'll be a situation where you are running that and you want to make this pipeline available to an experimentalist, maybe someone who doesn't know Nextflow, someone who doesn't know your pipeline, and you want to make them, you want to build a kind of a much easier form for them to do. So I'm going to go back and change, and now the latest version of the same pipeline that I have has something we've introduced, which is called the Nextflow Schema. So if I just edit this, I'm just going to choose not this one, but I want to use the latest version here. And I think I can specify this. I'm just going to update this here. Now, when I select this pipeline, this version has got something else added to it. And this is what we call the Nextflow Schema, which builds a customized form. This customized form has got, in this case, some input-output options, so the transcriptome itself. It's got the option to put in some reads, and it's got some option to put the outdir. Where is this coming from, and how does this work? Well, there's an additional file inside of the repository, which is used to generate this customized GUI for me for accessing that. And if I go into here, you'll see that there's this Nextflow Schema file. And this Nextflow Schema file, in the very basic term, has input-output options, essentially a list of this kind of high-level options. And then we have, for example, the transcriptome, the reads, the outdir. You can see that here it's choosing which icon to give it. So this is using the folder open icon. You can see here that you can define the description. So by writing this file, you are able to generate this thing that you want. Now let's go have a look at a little more of a complicated, a little more of a sophisticated one. And this is one that's in the community showcase here. If I go into the NF Core one, which is obviously a lot more detailed, it's more of a production pipeline. You can see that when I click on this, we get the form, and the form is much more detailed. The form has inside of it a whole bunch of steps, like really Boolean values. It has drop-down menu. It has the ability to select thing. It has, for example, help menu. So you can define exactly what the user should see. So it describes a little bit of information about the pipeline. It's almost like some documentation as you go along. So you can choose specific information around how that should be used. Which aligner do I want to use? Here you can see a drop-down. Maybe I want to use HiSat2. And then the pseudo aligner I wish to use is none. It provides a bunch of options, and you can build this now into your own pipelines for doing that, and obviously make them as complex or as simple as you want. You can have multiple forms depending on if you want to make them for multiple different use cases as well. There's another important thing that the pipeline itself, the pipeline Nextflow Schema is doing, and that is input validation. Input validation is really critical because when you go kick off that pipeline, particularly when you go from a cluster or cloud, it may start the execution, the Nextflow job gets submitted and runs. But from there, what happens if you have, let's say, made a mistake early on and that the actual files are not there, or that the file you specified, the input was wrong, and then you come back the next day and you see it's all kind of turned over and failed. Well, one way you can get around that is do what we call parameter input validation. And that is also specified inside of this form. So this is something which is one of the kind of newer features that we're building out with NF Core here as well. I'm just going to go back to the RNA-seq example here. Inside of this form, which is the Nextflow Schema, it looks pretty similar, but there's one slight difference here. Here there is an input section, and now we're specifying that the input should be a file path, so not a string. Even though it may look like a string because it's like the location of a file, it's actually a file path. And it has to match this MIME type, so a CSV file, that has this pattern. The file itself has this pattern. And the second part of it, it has a schema. So there's a schema associated with the input of this. Okay, so let's have a look now here. Where is that schema stored? Well, that schema is stored under assets schema input. If I go into here, and this is kind of stuff that you really just should set up once for your pipeline, shouldn't require too much. From inside this schema input here, you can see that we're defining that the object, the CSV file, has this structure. It has properties which are made up of a sample ID. It has properties made up of a fastq1, which is a string which matches this pattern, fastq2, etc. So you can either include a fastq, so basically is there two reads or not, And then you should specify whether it's the strandedness. So it's required that we should specify either forward or reverse or unstranded. Now, this means that we can validate our input prior to the execution of the pipeline. And the way that we can do that is via what we call data sets. And data sets are ways of inputting data into Tower, typically structured data, so typically TSV, CSV files, and they allow us to define exactly what that input should look like. This is really kind of more towards sequencing data, but any kind of structured data you can use like this. So here's an example of the basic sample sheet that comes in here. This data set has got this structure. So it's got a sample, fastq1, fastq2, strandedness. You can see the location of those files. In this case, it's an S3 bucket. You can also generate this automatically. So you can, for example, have a script which will automatically upload this via the API or via the CLI. And this kind of eliminates a lot of the kind of pain in terms of data management here. You can create different versions of these as you want to run through and update them there. The important point, though, is that from the Launchpad now, there's kind of two ways that you could think about doing this. The first way may be that you have to find a data set, and you would say, this data set matches that pipeline. Okay, I've got my data set. I know what kind of pipeline it will run. In which case you might say, okay, I want to annotate this data set with a pipeline. But instead of this, the way that this kind of went about was actually something which is, I think, is super, super smart. So the way that they thought about it was like, instead of doing it like that, what about the opposite? What about if we say the pipeline takes this kind of data? And in doing so, when we launch a pipeline now, it knows, because of the schema file, what the input should be, what kind of formats are accepted, how it works if they're validated. So when I go and select the RNA-seq pipeline and I start typing and I start searching for some data, it's going to get a drop down. And it's only going to show me validated CSV files which match this. And this is a kind of really nice pattern you can continue through, with your different aspects of the pipeline. You can use this, but it eliminates the need of finding those files as well and accessing that and doing that. And then you can kind of launch this pipeline off and sort of we're back at the beginning where we were for creating that. There's always the option for a launch setting. So to be more sophisticated launch, the advanced launch that we spoke about before, and linking that in as well. Okay, let's have a look now and not so much on the pipeline execution and the data set management and the basics of that, but what about the actual compute environments? And what does that look like in terms of creating those? So I'm going to change into my own workspace here because I've got a bunch of these set up, and we're going to set up some more as we go through and create this. So when we're launching pipelines, you can see that we can choose multiple compute environments, and these are things that are typically set up once. In your situation, they may be set up by an admin, but it's still important to know kind of what they do and how they can be used. When you can see that we're going to launch a pipeline against an AWS batch compute environment that we're set up here, we're going to then choose the pipeline. We show that it was kind of independent. Well, to set them up yourself inside of the computer environments, either in your own workspace or a shared workspace that you've got the correct permissions for, we can choose a computer environment here. And now I'm just going to create a new one. So I can go create a new computer environment here. I can give it a name, my EBI demo computer environment. And we're going to go through a couple of the different options that are available in terms of the platform. So I can choose Amazon Batch, which I've seen before. I can choose Azure Batch, Google Life Sciences, can choose LSF, and this is the way this connects in here. And we can also choose the different Kubernetes flavors. Let's start with a basic example of kind of Google Life Sciences. This is pretty minimal in the sense that there's not too much to set up. And if you remember from earlier in the day when we were doing the Nextflow config, you can see that many of the fields here have a direct mapping to that. And the reason for this is it means that you now no longer need to specify in your Nextflow pipeline a specific configuration in the pipeline, because Tower can create that config for you and essentially inject it into the pipeline when you wish to launch. So it's going to specify obviously some credentials. So it has credential management here. If I add in some credentials in terms of Google, it uses a service account file, it's a JSON file. We'll see a bit in a moment the credentials. We choose the region. It uses the API here to show us all of the different versions that we have. So if I want to go run this here and I want to go select that, I know that I've got this set up for me in Europe West 1. And then if you want to see, you can see different zones. There is the location. This is really kind of optional. And for us, the main thing, you've got a Google storage bucket. So in our case, we're going to run it against this work bucket. And you have the option here of using preemptible. This is the equivalent of Spot. So this is like much cheaper to use in terms of those virtual machines, but they can be pulled down at any one time. You also have the existing file store system. So this is an NFS system. So you don't need to use, if you want to basically mount a shared file system as part of that. And then you have staging options, so pre-run, post-run, really kind of ways that you can launch that, environment variables as well. And then there's a couple of options which are specific to the job. So in this model, and in the kind of the model that Tower works in all cases, Nextflow job, the head job, is submitted to that computer environment, and therefore you can choose what's the options to that. Now, I should point out, the Nextflow job should never go onto a spot instance or a preemptible instance, because you don't want your head job to essentially be decapitated and taken down from those instances as well. So Nextflow Tower handles already, so you don't have to worry about that as well. So to summarize, you can create multiple computer environments that can connect into multiple places that are separate from where Tower is installed, completely independent. Once you've created those, you can create them in a shared workspace so that users can come in and launch their pipelines against those computer environments. They typically just need to be set up once. And from there, the users can launch through either pre-configured pipelines, like some of the ones I've shown you here for RNA-seq, which have got all of the things configured, or alternatively, they can connect in and start running their pipelines if you're familiar with Nextflow pipeline itself. Okay, a few final things here around the credential management. So you can link in, for example, with your credentials of the cloud providers I showed you before, but you can also link in with your source code management. So if your code is private, so if you have, for example, your own private Nextflow repositories that you don't want to make public, you can add in your credentials here for GitHub. And from there, you can choose either the base one, which is basically the GitHub Cloud, the version that's there, or if you've got your own on-premise GitHub, you can use that. Likewise with the major, all the kind of Bitbucket, etc. Container registries, SSH, and Tower Agent we spoke about before. Participant management is a kind of key to this. So if you think about the participants, the way that you want to control this is mostly taking place at the workspace level. And here you can see I'm in this verified pipelines workspace, is the name of it inside my organization. And I can control the access and the role of participants inside of a workspace using this participants tab. And this enables me to add participants. So if they're already part of my org, I can define them. Here you can see I'm an owner. And this is really kind of almost like an admin role as well. So I can pretty much do everything. There's administrators who can create computer environments, credentials, etc. So that kind of management. Maintainers, typically bioinformaticians, people who are adding pipelines, changing parameters, selecting the computer environments for those pipelines, and then launchers, which can just see like the launch screen. They can choose a pipeline they wish to launch. They can choose some data set they wish to run, but they can't change sort of settings above that. Now, this is specific to the workspace. So you can have some workspaces where you can be an admin and some workspaces where you're a launcher. This can be defined completely. It kind of creates a bit of a sort of boundary around that as well. So it's inside of our organization here, you can see we've got multiple workspaces, members and teams for collecting those people together, essentially defining them and accessing them there. Other things that are important that we didn't mention so far is that all of this can be done from both API and CLI. And this is the way that it's published here. It's those two, the front end and the back end of the Tower application are fully separated. And they're kind of available via this publicly available API. What that means in practice, if you go into here inside the docs and you go into API endpoints, you can see anything here that you can see really actions, I'll speak about in a moment, computer environments, credentials, etc. can all be controlled from this, and the CLI does a good job of that. Sometimes the API is quite detailed though, in the sense that it has a lot of options and you want to kind of easy access, particularly around automation, triggering the execution of a pipeline, maybe making the pipeline run when your data is gone, is sort of ready. And for that, we have what are called actions. So I'm just going to go back to the showcase here. Actions are automated ways to trigger the execution of a pipeline based on an event, based on a trigger, based on something you define. So you define the pipeline you wish to launch plus the trigger. There's a couple of triggers. One of them is a GitHub webhook. So when I commit to this repository, the workflow inside there will automatically execute based on these settings here, the same as setting up a pipeline. And this is because it's obviously a nice way to have for continuous integration. So if I go into here and make some changes to my pipeline, and then when I commit, it's going to test that those changes I've made actually run. And similar to GitHub Action, but you could think that we're running here in a distributed environment. So GitHub Actions will run typically on a small VM. And then from there, here we're kind of running it at scale. You can create custom endpoints. So this is what we call a tower hook. And this means that I can create a pipeline, and then I can create that the trigger here is an event source, which is a Tower webhook. That means that this endpoint becomes available inside from Tower. And when I link this in, so I could say, have some other system that's going to trigger this is going to run this pipeline with these parameters and run through. Other things that related to this, there is, of course, the Nextflow Tower CLI. And this is, if you're comfortable with the CLI in terms of the way that Nextflow runs, this is something we released just at the end of last year. And the way this works is you can say Tower launch and you select it in there. This also connects into your instance of Tower Cloud, sorry, of Tower itself. So you can connect this in with whatever instance of Tower you have. You can define resources in Tower using the CLI. So what I mean by this is it enables you to say, define my pipeline is made up of this workflow and it's got this revision, and all of that can be defined as a JSON file with all of that information. And means you can import and export. It means you can create the whole set of resources in Tower as part of that. And then from there, you can really copy that. Maybe you want to create different workspaces, add users, etc. via this. And it acts like as a kind of an infrastructure as code like setup. So you can define all of those things and very easily import them and export them there as well. I think that's kind of the main things that are available. Currently, we have obviously a pretty large sort of roadmap in terms of development of Tower and also in Nextflow itself. So there's always a bunch of stuff that's out there that we are pushing in terms of that, and always happy to get your feedback. And it's really fantastic to have both EBI and Sanger on this, and also providing us feedback so that we can make sure that we can really build the right features there. I hope that you got something out of the workshop as well. I would other things that I would say, if you want to follow Nextflow on Twitter, that's kind of a great place to keep up to date with the resources that we have. So as we have blog posts or new features that come out, there's obviously the Slack channel, which we just created this week. So I'm sure that will pick up if you've got questions around the training as well.